Okay, you got a polynomial. Again, find a point of inflection. Looks pretty simple to do. So you get f prime, and you're going to get 4x cubed, let's see, plus 15x squared, minus 72, right? Second derivative, that's going to be 12x squared plus 30x. You know what, I forgot to put the x there. It's 72x, minus 72. All right, what I would do is I'd try to factor this guy, because the quadratic and quadratics, generally speaking, are fairly easy to factor. So I'm going to pull a 6 out initially, because each of those numbers have a 6 in common as a factor. So we get 2x squared plus 5x, and that's going to be minus 12. All right, so 6 times 2 is 12, 6 times 5 is 30, and 6 times 12 is going to be 72. I'm going to make some attempt to factor it. I really don't want to do the quadratic formula. I'm going to say 2x and x. And then I'm going to say 3 and 4. Let me just look at it. I get 2x squared. I do get the 12. I get negative and positive in the middle. So it looks like this over here. When I say it looks like that, I still want to check it. You do get 2x squared. That works. You get 8 minus 3, which is 5. That works. And you do get minus 12. So what do I have over here? The domain is all real numbers. I'm looking at the second derivative. And I got the two critical points. One is going to be minus 4. That's where this factor takes on a 0. And the other one's going to be at 3 halves over here somewhere. What are you going to do now? Take a test point on those intervals. And I'd say like over here, a good test point here would probably be 0. If you plug it in, and you're plugging it in to the second derivative, this thing over here, should be relatively simple to do. What do you get? Positive, negative, positive. Overall, it's negative. What does it mean? It's concave down here. All right? When I say concave down, the function's concave down. Now, what do I do next? After 3 halves, which is a good point to choose, I'm going to say like 100. That's after 3 halves, by the way. You can choose any number you're comfortable with. But if you plug it in, everything's going to be positive, which means it's concave up. Now, if you go over here and take a test value here, again, I'm going to play it safe, minus 100 as a test point. What do you get? Positive, negative, negative. Overall, what are you going to get? Positive. So I got 2 points of inflection. I'll write them down for you, the POIs. What's it going to be? One occurs at minus 4 because the concavity changes. So minus 4, f of minus 4. No, I'm not going to compute that. The other point of inflection is going to occur at 3 halves. F of 3 halves. All right, let's look at the key, see if we got that. First, did we get the first derivative? Let's take a look at that. I think we got that right over here. Let me see if I did that. 4x cubed, yeah. Did I get the second derivative? I think so. It's right over here. I also wrote this one down as well. All right, looking good. Did I get the points of inflection at minus 4? I did. And at 3 halves. That's looking good. Now again, I want to point out, I'm going to kind of read it to you, but I know it's concave here from minus infinity, concave up from minus infinity to minus 4, and concave up from 3 halves to infinity. Let's see if they said that. Concave up, minus infinity to minus 4, and then you got the 3 halves to infinity. Concave down between minus 4 and 3 over 2. All right, thank you.